All right. So those people that are just joining us, we're doing chapter 2, 3. We're looking at goal number 3, using a graphing calculator to approximate maxes and mins, and then we're looking at increasing and decreasing. We just went to y equals. We went to y1 and we graphed x cubed minus 3x squared plus 5. So we just graphed this guy. They gave us an interval from -1 to 3. That's my x min and that's my x max. So we started in zoom 6, which is zoom standard, and that's too big. That's from -10 to 10. They asked us to go it from -1 to 3. So I went to my window and I changed my x min to -1 and my x max to 3. And then I graphed it. Okay, and this is the graph that you should get. So again, I went to y equals. I typed in x cubed minus 3x squared plus 5. I went to my window and I changed my x min and x max to -1, 3. And this is what I got, this nice, pretty little curve. Okay? It's like a roller coaster ride. All right, now I'm going to sketch this out. You don't have to, but it's always nice to sketch it out. Looks like we got something like this. Okay, so it starts down here, goes up, comes back down, like that. Okay, and it said it went from -1 to 3. Okay? All right, now they want us to find the local maximum. How many maxes do you guys see from -1 to 3? Where do you see them? How many do you see, guys? I got the 1. All right, so I got 1. A maximum is where it goes from increasing to decreasing. So look, it's like right about there. Okay, so let's find that point. So I press second trace. Second trace is the calculate menu. And guess which one we're going to press? Show me your fingers. Which one were you going to press? Second trace number. Shaylee gives me the 4. We're going to 4. We're doing maximum. So go down to 4 or press the number 4. And now we want maximum. Okay? Now, you guys agree we think this is the top of the mountain, right? So the first question they're going to say is, hey, what's the left bound? So basically they say, hey, get to the left. That's the left of that point. So I'm going to move my cursor with the directional pad, and I'm going to press enter somewhere on the left, somewhere from left to right where it's increasing. Okay, so I'm going to press enter. Then it says right bound. So get to the right of that point, somewhere over here. I'm going to press enter. Okay. Now, for me, I have a TI-84 colored edition. I've got arrows pointing towards the middle. Okay. If you ever have arrows pointing out, you have your lefts and your rights mixed up, which happens. Okay. So make sure you get to the left. Remember, left, if you do this, the little L sign with your left hand, that's an L. This is not an L. That's a backwards L. So make sure you get to the left. Okay. Press enter, get to the right, press enter. Now, last but not least, guess. This is where you press enter, and it jumps to the highest Y value between the points you picked. It jumps to the maximum. Okay? Now, today, I got this weird answer. I got 1.2533e to the -7. My guess is you did not get that, but I bet you got something with an e in it. Okay? Now, do you guys know what that means? What is it when you have an E in your answer? Does anybody remember from chem class? Lindsay, you remember? Tyler? Faith? Johnny, you remember what E is?
Times 10.
Yeah, it's times 10. It's scientific notation. Okay, so when you have scientific notation, if I have 1.25 times 10 to the -7, that means I need to move that decimal place over 7 places to the left. So if I take that and I do that, that'd be like 0.00000000125. Well, if I round that, that's 0. Okay. So round this guy. That is not the answer. Anytime I have an E in it, I always think of an egg. Okay, that's going to be 0. So I have a local maximum right here at 0.5. So at 0.5 is my maximum. All right, let me zoom out a little bit. All right, any questions, y'all? Now, again, you probably got a different answer, but I guarantee you had an E in it, unless you're lucky enough to get 0. Why does it do that? It's a pixel issue. Okay, TI-84s, 83s only have so many pixels. They're trying to get as close as possible with the X value. They just can't get all the way to 0 for whatever reason. Okay, at least that's my answer for you. I don't know any other reason why that would be the case. All right, ladies and gentlemen, we got the maximum. Any issues there? Anybody not getting the maximum? I hope you're trying this at home. I can't be sitting there watching you. I can't see your hands. We're okay. I'm doing fine, Mr. Gotsch. Let's do the next one. Okay, let's do it. The next one I want is the minimum. So we do it again. We press second trace, and I want the minimum. What number is minimum? I get the 3 back at me. So you guys are saying 3. So I toggle down with the directional pad, or I press 3, the number 3, and I press enter. Okay? All right, so we agree right here is the minimum, right about there. This is the left, this is the right. So left bound, I get to the left, somewhere where it's decreasing from left to right. I press enter. Right bound, I go to the right of that point. I press enter. Notice for me, if I have an 84, my arrows are going towards the middle. They're going towards that minimum. Okay? So now if I press guess, your graph is going to find the lowest Y value between the 2 points that you picked. So I press enter, and I have 1.9999999, comma 1. Some of you guys might have got 2.00000000001. Okay, we always want to round these. It's a pixel issue. Okay, you can't get exact. So if I round to 1.9999999 or 2.00000, then that point right there is going to be 2.2 comma 1. Okay, anybody not getting 2 comma 1 there? Whether it's 2.000000001 or 1.999999994. Anybody having issues, y'all? This is the time, like if you're like, Mr. Gotsch, I don't know how to use this calculator, walk me through. This is the time to ask as we're going through it in class. Just like if I was with you in class, you'd raise your hand and say, Mr. Gotsch, I don't know what I'm doing. You guys are fine. No issues. No problems, Mr. Gotsch, I guess. All right. Now, common mistake people do. Okay? Common mistake. We agree that's where the minimum is. This is the left, this is the right. Every once in a while, you're just trying to get this done, you're not paying attention, you go minimum. And they go left bound. They go over here. And they press enter. Right bound, they go to the left. And press enter. Notice my arrows are pointing out, right? It's backwards as opposed to what it should be. If they press enter now, you're going to get an error bound. Okay? And that just means you have your lefts and your rights mixed up. Okay? So go back to your L's. Make your L's with your hands. Oh, yeah, left is on the left. Right is on the right. Okay? So that's a common mistake people do every once in a while. They're going too fast. Okay? So don't get your lefts and your rights mixed up. Other common mistake, they go second trace, maximum, and they want to find this minimum. They go left bound. Then they go right bound. And then they do guess. And when it jumps to the maximum, it jumps to the highest Y value of the points that you picked. Well, that's clearly not the minimum. And in fact, it says maximum. So you have to see like, oh, that didn't do what I wanted to do. So maybe you picked the wrong thing when you I have fat fingers. Maybe you press 3 instead of 4 or 4 instead of 3. Okay? So watch out. All right, ladies and gentlemen, that's your mins and maxes on your graphing calculator. Pretty easy stuff. Let's do to the next part. The next part of the question you're going to see on my math lab says determine whether the function is increasing and decreasing. Okay? Now, it will be over the interval that is given. Our interval is at -1 to 3. Okay? So I want to know where this thing is increasing. So I look at my graph. What's going on? This graph is doing what? Is it increasing or decreasing to start? What do you guys got? Increasing or decreasing? Aiden, what do you say? Anna, what do you say? Natalie, what do you say? Anthony? Increasing. Very good. So it's increasing, increasing, increasing. It's increasing from this x value to that x value. Okay, remember we're talking intervals. Make sure we're talking x values. So it starts at -1 and it goes all the way up to 0. Then it switches gears. So at 0, it's neither increasing or decreasing. It's switching from increasing to decreasing. It's going down. It's going down. It's yelling, timber, you better move. You better dance. Hashtag Kesha goes from 0 to 2. It's decreasing. Remember, x values. Last but not least, it switches gears again. And it's going up. It's going up. It's going up. Now, is it going all the way to infinity? I don't know. We're using the x values that are given to us. So is it going to infinity? It might be. But use what x values we have over that interval. So from 2 to 3, it's going up. Okay? So the most common mistakes is people do -1 and 3. Instead of -1 and 3 here, they put negative infinity to infinity. Well, they only want it from this snapshot, from here to here. Your graph does not go to infinity. It stops at -1 to 3. Okay? You cannot do increasing and decreasing unless you have your mins and maxes. You have to find those first before you can do this part. Okay? And in my math lab, it walks you through it. It's first thing they do is say, hey, give me the mins and maxes. Find the mins and maxes over this interval. Then you can do increasing and decreasing. Do you guys have any questions with that, y'all? No questions. Mr. Gotch, this is so easy. All right, can I get a thumb up? Give me a thumb. Where are we at? Because I'm not getting much response from you guys. Thumb, I'm getting a thumb. All right, no questions. Fantastic. Thumbs are in the air, waving around like you just don't care. Here we go. Last but not least, and then we'll be done with these notes. This is it. Real world applications. Real world applications. Okay? Says an open box with a square base is required to have a volume, length times width times height, volume of 10 cubic feet. The amount A of a material used to make such a box has a function of the length x of a side of the square base is A of x equals x squared plus 40 all over x. Graph A and determine where A is the smallest. Okay? Now, if you didn't understand any of the stuff that they're talking about, that they're trying to have a square base of a box and they're trying to get a volume of 10 cubic feet and they're talking about the amount of A of material of a box, this is the material that's going to be used for the box, that they want this to be the smallest. If you didn't get any of that, here's the big idea. You need to graph this and we need to do the smallest of that. Well, from what we just talked about in chapter 2, 3, what's another word for smallest? What are we going to find today? What's another word for smallest from the words we've been using today? Minimum. We're going to find the min. Okay? So if you didn't get anything that's going on here, that we're trying to get a volume of 10, but we're trying to minimize this material so that we save money, well, at least you see a function. When in doubt, graph the function. So let's graph it. I've got x squared plus 40 divided by x. So I have x squared plus 40 divided by x, and I always have y to 0, don't have to. I'm going to start in zoom 6, and I'm going to see what do we get here. We get something over there, and we get nothing on the right side. Okay? Now, x values. We're looking where x is the side length, so we're really looking at the positives here. Yeah, I don't see any positive values. I only see negative values. So right now, this graph in zoom 6 is not very good. Is anybody not getting this graph in zoom 6? So this graph is not helping us at all. Okay, so what we need to do is let's zoom. And I like to go to zoom 0. You see zoom 0? Zoom fit. So this, if I press zoom 0 or zoom fit, this is going to fit the graph a little nicer to my screen. Okay? So it's going to try to zoom out enough so that you can fit as much of the graph on as you can. Okay? Now, we do not care about the negatives. There's no way that we can have an x value that's negative because that just doesn't make sense. If x is the side of a square base, there's no negative x value. So we're only caring about this guy right here. Okay? So the graph starts decreasing, and then it bottoms out, and it starts increasing. Well, we talked about where we want to find where this graph is the smallest, where the y value is the lowest. And that's our minimum right there. Okay? So all we do is we do what we just did. This is the left, this is the right. I press second trace is the calculate menu. The same menu that we use to find the zeros of a function, to find the value of the y-intercept. So I go down to minimum, number 3. Left bound, move your cursor until you can see it on the left. So I went to the right, and there it is. It's on the left-hand side of that minimum, so I press enter. Right bound, get to the right where it's increasing. The graph is going up and up and up and up. Anywhere over here is fine, press enter. And then guess, press enter. And I got a minimum, for me, I got 2.714418, comma, 22.104. Okay, so graph and determine where A is the smallest. Where is it at is the x value. So x is going to be 2.71, and we're talking about cubic feet, so this is in feet. Okay. If they want the actual minimum area, that's your y value, and that'd be 22.10, and that would be cubic feet. So feet. So area would be squared. We're talking about A is for area. On the material, we're talking about a square footage of probably cardboard. And there we go. So we got some applications of finding mins and maxes. If you have a cost function, you want to minimize cost. So if you have C of x equals, probably going to minimize that. If you have a profit function, usually we want to maximize our profit. So you're going to find the max of the profit if you have a P of x function. Ladies and gentlemen, I am officially done with chapter 2-3, day 2. Is anybody having issues or questions?